Every system eventually needs to remember something: a user account, an order, a document. In this video, we focus on the tier responsible for that, the data layer. We will look at what it contains, why it is deliberately kept separate from the rest of the system, and why it is almost always the hardest tier to scale. Imagine a codebase where a button click in the UI talks directly to the database, and a pricing rule buried in a helper function does the same. When your schema changes, you hunt down every caller. When you need to restrict who can read sensitive data, there is no single place to do it. This tangled dependency is the pressure that makes a dedicated data tier necessary. Picture a secure archive room in a large office. Nobody enters freely. There is one clerk at a window who controls all access. You ask for a record, the clerk verifies you are allowed to have it, finds it, and passes it through the window. The data layer works exactly like that clerk. It is the one control point through which all stored information must pass. In a three-tier architecture, the presentation tier handles what the user sees and touches, the business logic tier applies rules and makes decisions, and the data tier is responsible for storing and retrieving everything that must persist beyond a single request. Crucially, the data tier sits at the bottom. The presentation tier never reaches it directly. Only the business tier may speak to the data tier, keeping the boundaries clean and controlled. Follow a single request from top to bottom. A user submits a form in the presentation tier, which passes the intent, not raw data commands to the business logic tier. The business tier validates, applies rules, and only then calls a data access component, which is a small piece of code whose sole job is to translate that request into a database read or write. The result travels back up the same path. The key consequence is that the data store is never exposed directly to the outside world. Isolating the data tier gives you real concrete benefits. A schema change only touches one tier, access control lives in one place, and replacing a database engine does not ripple across your entire codebase. The one honest cost is that the data tier remains the hardest tier to scale regardless of how well you isolate it, because data is stateful, and state demands consistency. Spreading data access around saves a little in direction, but only ever makes sense for the smallest, most short-lived scripts. In practice, the most important habit is routing every storage call through a dedicated data access component, often called a repository or data access object. This single rule prevents the coupling that makes systems brittle. Because the data tier is the hardest to scale, you should think about caching, read replicas, and partitioning strategies early, not after you hit a performance wall. And treat your database schema with the same discipline as your public API. Changes to it affect the whole system. To summarize, the data tier is responsible for everything that needs to outlive a single request, and it exposes that information only to the business logic tier, never directly to the presentation tier. That isolation keeps your schema changes contained and your security rules in one place. The unavoidable challenge is that state is hard to distribute, so the data tier will always demand the most careful thinking when it is time to scale.